All right. I think we should get started. Thank you, everybody, for coming. It is great to see this crowd. So I just want to say good evening. That was pretty good. Okay, so for those of you who have been in my classes, you know that we are not going to move on until we get an awesome response to that, right? So, yeah. So good evening. Oh, that just warms my heart. Thank you so much. For those of you who don't know me, I'm Lisette DePillis, the chair of the math department here at Harvey Mudd College, and I want to welcome you to the Fall 2016 Michael Moody Mathematics Lecture. Thank you so much for being here. I want to tell you a little bit about the lecture, and then Professor Burnoff is going to come up and tell you something about our amazing speaker, and then we get to see an awesome talk. So let me give you a little bit of background. Michael Moody was a cherished friend, mentor, and inspiration to the Department of Mathematics. Mike came to the college back in 1994, and in 1996 he actually became HMC's first Diana and Kenneth Johnson professor and was named the chair of the Department of Mathematics at that time. During his time as department chair from 1996 all the way through 2002, the department hired 8 new professors, bringing the total number of math faculty to 12. I should say we didn't start at 4. There was a little bit of turnover. So Mike wanted people who would mesmerize and inspire students in the classroom and who had a passion for their mathematical work. He gave the department what he called an animating goal to be recognized as one of the very best undergraduate programs in the country. The department actually credits Mike Moody as being the guiding force leading to the reception in 2006 of the inaugural American Mathematical Society Award for an exemplary program or achievement in a mathematics department. The Harvey Mudd College Math Department was singled out for this honor among all of the graduate and undergraduate mathematics departments in the United States. Yeah, you can applaud at that, because that's a You're allowed to make some noise. It's okay. At the time of Mike's death in 2010, Mike was Vice President for Academic Affairs and Founding Dean of Faculty at Olin College in Massachusetts. That spring, the Harvey Mudd College Alumni Association recognized Mike Moody as an honorary alumnus to commemorate his many contributions to the college. This Moody lecture series was established by the math department to honor Mike's legacy at Harvey Mudd College, and it has been supported by gifts from Mike's family, friends, colleagues, and former students. And I should say, would not be in existence without the leadership and dedication of Professor Andy Burnoff as well, who initiated the whole effort for this lecture. So I want to thank the math department, and especially my colleagues Andy Burnoff and Art Benjamin for helping with this lecture, and most important, Jocelyn Olds-McSpadden, our amazing departmental administrative aide. Without her, this lecture never would have happened. So thank you to all 3 of you. I really appreciate that. Now I would like to invite Andy Burnoff up to introduce tonight's speaker. Let's give him a round of applause.
So thank you, Lisette. This is actually the 11th Moody lecture. And it's just great to see such an amazing crowd here. It's a real pleasure to welcome Karen Saxe. Karen is from Macalester College, and the first thing you need to know about Karen is she's passionate about using mathematics to make the world better. So tonight she's going to tell us how you can use math and statistics. Are there any Math 35 students here? Okay. Pay careful attention. And she's going to tell you how to use math and statistics to quantify things like social inequality, and then what you can do with that. So Karen is the DeWitt Wallace Professor of Mathematics at Macalester College in St. Paul, Minnesota. I might add that Macalester is where I spend my summers doing research with some of my colleagues there. Karen has an office just 2 doors down. She keeps an eye on me, keeps me in line. Okay. She's been awarded a Distinguished Teaching Award by the Mathematics Association of America and the Macalester College Excellence in Teaching Award. She is very active with policy and advocacy activities for both the MAA and the Association of Women in Mathematics, and will assume the position of director of the Washington, D.C. office of the American Mathematical Society on January 1st. She'll work there with the mathematics community and Washington decision makers who impact science and education funding. And I'm really glad she's going to be there advocating for us. So, Karen has been a resource in Minnesota on redistricting, which is very appropriate as we go into the election season. She worked on the Minnesota Citizens Redistricting Commission, which was created to draw congressional districts following the 2010 census. On her most recent sabbatical, she served as the 2013-2014 American Mathematical Society, American Association for the Advancement of Science, Science and Technology Policy Congressional Fellow, working in Congress for Minnesota Senator Al Franken. So Professor Saxe's lecture today is entitled Mathematics and Social Justice. Please join me in giving Karen a warm Harvey Mudd College welcome. Go get him.
Hi, everybody. I feel like I should quit while I'm ahead somehow. But, okay, first I have a question. What the heck is Math 35? Okay, got it. Okay, so thanks, everybody, for coming out tonight. And it's true that Andy spends the summers in Minnesota, where I've been lucky to get to know him. I also know several other members of the department already, and I'll be hanging around for the next couple of days, hoping to get to know more of you. How many of you are first-year students? So thank you guys especially. That's like everybody, except for a little cluster down here. But thank you especially for coming out tonight. Okay, I'm sure that all of you feel privileged to be at such a great school. I mean, Harvey Mudd really is great and has won this award, but that's, you know, just one of many accolades. It really is a terrific place. I know I'm privileged to be where I am, and I've kind of always been privileged in my life in a way. So a lot of what I'll talk about tonight will come from perhaps a place of privilege, I'm not sure. I hope it doesn't seem hypocritical or patronizing to take on some of the subjects that I'll be discussing. I think the challenges that the country faces having to do with inequality of income, of wealth, and of opportunity are so great that it really takes all of us, and there's so much work to be done. I mean, everybody needs to contribute. So I'm looking forward to talking about two of my favorite topics to teach, calculus and redistricting, and also about my personal feelings about social inequality in politics. As a side note, it won't come as a surprise that I'm following the elections right now very closely, and in addition to teaching real analysis right now, I'm also co-teaching a political science class with a political science professor on the elections and on political participation more broadly, and I'd be glad to talk about any of that at the end of this. So on to the talk. Okay, so when I see a plot like this, I kind of get interested. We see two things that appear to follow the same trend over decades. The Gini Index in blue is a common way to measure income inequality, and the polarization index in red is a common way to quantify how far apart conservatives and liberals are in the U.S. Congress. Over the next 40 minutes or so, I'll explain what the Gini Index is and discuss quantitative ways to determine whether or not gerrymandering has taken place. I'll end with a personal backstory to frame a brief discussion about the role that education in the mathematical sciences can play in narrowing the inequality gap. So before I start, I want to raise two questions that I'd kind of like you to have in mind throughout the hour, and I'll put them up a couple of times later on. So the first is, can mathematical concepts help us to understand and analyze social inequality? And the second one is, can learning math and the possession of mathematical knowledge actually enhance an individual's social mobility and therefore help alleviate social inequality? As you might now conjecture, I think the answers are yes to these questions. So the first plot I showed you used the Gini Index to measure inequality. This measure is a pretty straightforward quantity, and if you've taken calculus, you'll understand it. It uses an integral of one variable function, and I'll tell you exactly what this is in a minute. But before we look at the Gini Index, I want you to reflect on the information on this slide. So I kind of want to know how you respond to all these numbers. It might take a little while to take it on board. So if you had the huge amount that Chipotle has for its payroll, I think Chipotle is the second one, is that how you'd think to distribute the money between the CEO and the other employees? Okay, look at that. Okay, and then what about Oracle, which is down here at the bottom? Okay, so you can see this sort of thing. To understand the Gini Index, consider a scenario in which you're paying people on payday a total of $100. So I've got these 5 people here whose names are going to be Abby. Oh yeah, they have their names on the slide. Abby, Ben, Colin, Daphne, and Ed. And Abby gets 5 of the dollars, Ben gets 10 of the dollars, Colin gets 20, Daphne 25, and Ed 40. And I've put these numbers at the top of the next slide so you don't have to remember them. Okay, this information about pay gives us points on the so-called Lorentz curve. Abby alone constitutes the bottom, so you have to sort of follow along, and I know it's the evening here, okay? So Abby alone, she constitutes the bottom quintile, or bottom 20% of our population, and she makes 5% of the total income. This gives the first point up there of 0.2.05. The 0.4.15, that one, okay, means that the bottom 40% of the population, Abby and Ben together, make 15% of the total income. And the 0.6.35 means that 60% of the population makes 35% of the total income. And the 0.8.6 means that the bottom 80% of the population, that's everybody except for Ed, makes 60% of the total income. And the 0.11 means that the bottom fifths, that's the bottom 5/5, sorry, that's everyone makes all the income. The 0.11 is always going to be on this curve. And I should say, like, I'm used to having a class, you know, where I want you guys to interrupt and ask questions. I'm not sure that's totally appropriate, but if I'm going too fast or something, you should say something, okay? And can you hear me? Everybody can hear me? Okay, good. Also, the 0.00 is always on the Lorentz curve. So I've plotted these points in red and connected them together with line segments. I've also drawn the diagonal in blue. The area between the two curves is calculated and then doubled, and the resulting number is the Gini Index for the given income distribution. Okay, that's it. So in practice, we usually have more than 5 data points, and we don't usually connect them with line segments, but we use some techniques from curve fitting, calculus techniques to fit a smooth curve to the points. Okay, and here's a Lorentz curve with some more points, still not a lot, but some more, and a curve vaguely fitted to those points. So hopefully you will now recognize the Gini Index as an integral. The Gini Index always turns out to be between 0 and 1, and you may or you may not wonder why we draw the diagonal. And this is because it represents the ideal state of things here, an ideal state in some way. So to see this, think about what happens if the income is fairly distributed. And fairly is a word that we can talk about. And what I mean by that is each person makes $20 out of the 100. So in this case, Abby alone makes $20. So we have the 0.2 on the curve. And then the bottom 40%, which is Abby and Ben together, they make 40% of the total income. And so 0.4 gets to be on the curve, and so on. Okay, all the new points lie on the diagonal. And if you think for a second, what happens instead if Ed makes all the income and everybody else makes nothing? So then what would happen? What would all the points look like there? Okay, they'd all be 0, 0, except for the last one, right, which would be 1, 1. So in other words, the red dots, okay, there we go. All the red dots except for their very last one would lie down on the horizontal axis like you see in the second picture, and the shaded area is as big as it can possibly be. It's the triangle with area half. The Gini Index is 1. Remember, you double it. Okay, so the two extremes are a kind of good Gini Index of 0 and a bad Gini Index of 1. Gini developed his index in 1912 and was building on work of Pareto and Lorentz. And if you're interested in the history of efforts to quantify income inequality, you should probably start with the work of these three. Pareto's first work included a famous but much criticized law of income distribution. It's a complicated formulation in which he was trying to prove that the distribution of incomes and wealth in society is not random, and that in fact a consistent pattern appears throughout history in all parts of the world and in all societies. And then Lorentz did his work while he was working at the Census Bureau in 1910. Okay, he developed the curve a few years before that. Okay, there are other measures of income inequality, and I'm not going to talk about them, but they all have their pros and cons. The Gini Index is one of the four the Census Bureau uses. And as a September report of the Census Bureau shows, the Gini Index was significantly higher in 2015 than 2014 for the United States as a whole, and for 8 individual states. It's about 0.48, so about a half right now. There was one state whose Gini Index decreased that year. Any guesses? No, not California. Sorry. Second guess? No. No, it's actually Connecticut. But, I mean, things are strange because when I gave this talk last year, the year before, there was also only one state whose Gini Index had decreased, and it was Mississippi. So it's kind of, you know, I don't know, whatever. Okay, Gini's measure, it's considered the gold standard. You can compare between units with different size populations. On the negative side, it's sensitive to transfers of income in the middle range, and this box at the bottom is supposed to show this. If you look, the Abby and Ed's salaries stay fixed, but the middle range changes quite a bit. Gini indexes changes also. So it doesn't tell you about the top 1% or the bottom 1%, things like that. Okay. Further, you need a lot of data to compute Gini indices. And the varied systems around the world for taxes and transfers can make it really difficult to compare across countries. And what I mean by the different systems of taxes and transfers are we talking about income before things like Social Security is taken out, before food stamps are taken into consideration, and unemployment benefits? It's very different in different countries, so we have to think about this. A further criticism, which isn't listed here, is that an individual's income can vary hugely over time. I mean, one year you might be unemployed, and the next year you might be making a ton of money. So it may not reflect at any one given time the resources available to a person, like accumulated family wealth can. And economists generally think of 3 similar but distinct metrics of economic disparity: inequality of income, inequality of consumption, and inequality of wealth. In general, wealth is the most unequally distributed of the 3. Consumption is the least. Income inequality is the most commonly cited measure, primarily because data on it is most accessible or easy to access. But for the purpose of measuring how inequality affects a community, it's probably the least interesting yardstick of the 3. If you think about people's living standards, they depend more on the amount of goods and services that are consumed by a person, rather than the number of dollars they make. Consumption is also thought to have diminishing marginal utility. And what I mean by that, you probably know, but a poorer person will value an additional unit of consumption more than her richer friend will. So spreading consumption equally will maximize aggregate welfare in a society. When wealth inequality increases, the lottery of birth becomes increasingly important in determining living standards. So it's kind of interesting to think about the 3 compared to each other: income, consumption, and wealth. Consumption and income inequality have risen together over the past 3 decades. The relationship between wealth and income inequality is not so clear. They're positively linked for several countries, such as the US, where inequality is high, and South Korea, where it's low, but they're negatively linked in other countries. Within countries, however, all three measures have a positive correlation with each other. Okay, so there might be a bit on there to take on board. So let's return to the graph that we started with. We now understand, or at least I've explained, what the blue line is measuring, the Gini Index. So notice that the scale on the right, varies only from like 0.35 up to 0.5. And I mentioned before that the Gini Index right now in the country is about 0.48. The polarization index shown here in red measures how far apart conservatives and liberals are in the House of Representatives, as measured by looking at their roll call votes. So I'm going to talk more about what I mean by that. So we know, for example, that Nancy Pelosi, who's the Democratic representative from California District 12, is more liberal than, say, Paul Ryan, who is the Republican from Wisconsin District 1. He's more conservative. But how do we quantify the difference? Well, nominate. Has anybody heard of nominate scores? Okay, excellent. Good. This is a quantitative procedure that scores senators and House members directly from their roll call votes. When I say the word nominate, it's the word, but it actually is an acronym. And the measure shown in this plot here is a variation on the procedure called DW nominate, which stands for Dynamically Weighted Nominal Three-Step Estimation. It was developed in the 1990s by Keith Poole at San Diego, Howard Rosenthal at Princeton. And I'm going to give you an idea of how it works. This will be more superficial than the explanation of the Gini Index. So each year there are hundreds of roll call votes in the House. You can look online and find these, all of them, if you want to. This particular vote in the House took place on July 14th and was about regulations regarding funds for Iran. The vote was partisan, with 240 of the 246 yay votes coming from Republicans and 178 of 181 nay votes coming from Democratic members. Of course, votes in the House aren't always partisan, and representatives don't always vote in the same coalitions either. In this table, the names in italics are Democrats. And I guess, whoa, I didn't mean to do that, sorry. Go back, I meant to do that. See that guy? Anybody know who he is? Okay. Well, he's a Democrat. He's from Nebraska's 2nd District, and he votes against his party nearly a third of the time. Okay. So when I talk about my own personal background and this next thing also, I realize that for college students, this might not be so familiar. But we can talk about the Southern New Deal Democrat. And I don't know if that even means something to some of you. But this would be a legislator who, for example, voted for liberal economic positions, but voted against anti-lynching legislation. So there was a remarkable senator named Strom Thurmond from South Carolina, and he was a good example of this kind of Democrat at the beginning of his career. He was a labor-friendly segregationist. He advocated for expanding workmen's compensation laws and better working conditions in plants and factories. This is, of course, a liberal view. On the other hand, he was very much against the Brown versus the Board of Education decision, which I'll talk about in a little while again. In 1964, he switched parties and became a Republican, and he in part switched because of his opposition to the 1964 Civil Rights Act. So let's get back to the nominate scores. The DW nominate scores use all roll call votes to place each representative on a linear scale, and then uses a difference of the means for the liberals and the conservatives. So this image shows scores for the House members according to all roll call votes taken so far this Congress as of September. So by this measure, Representative Raul Grijalva, I'm not really sure how you say his name. He's a Democrat from Arizona District 3. He's the most liberal member of the House of this Congress, and he would be that person, over there. Okay, and then Representative Walter Jones, who's a Republican from North Carolina's District 3, is the most conservative, and he'd be over there. I think some people might be a little, well, I don't know if it's surprising, but you can see where Pelosi and Ryan sit. They kind of sit at the median of their own party, which is sort of interesting. We can also look at these nominate scores over time. Around 1960, so it might take a second to think about what this is showing, they appear closest together. Since then, we see increasing polarization with a notable shift by conservatives moving further from the center. So why is our Congress more polarized in recent years? Maybe I'll leave now. Okay, well, some people think it has to do with redistricting, or rather the activity known as gerrymandering that takes place during the redistricting process. And the argument that gerrymandering enhances polarization is that it basically makes it easier for more extreme candidates to win elections and re-election. So the redrawing of congressional districts happens every 10 years. It's the third step in a three-step process. The first thing we do is we count everyone in the country. The census is used for many things now, but it was first mandated in our Constitution to determine the population of the states in order to do the apportionment of the House. So the second step, where we reapportion or reallocate the 435 House of Representatives seats to the states, and then the third step is when we redistrict each state to partition each into district, one district per seat. Okay, these three steps are now like a very large, long, and complicated business. So at the end of this process, each state ends up looking something like this. Okay, so where are we? What district are we in? Which one are we in? Someone's got to know. There? 27? Okay, 27. Yes? Okay, we're in 27. How many districts are there in California? All of them. Okay. There's 53. Okay. So it all looks interesting. You know, why is this one so big and that one so tiny? Okay. So when the districts are redrawn, there are three criteria that must be satisfied. Okay. Each district has to have the same population, and this is very easy to check and achieve when you're drawing your plans. And you can prove pretty easily, if you're a math student, you should prove this, that you can have plus or minus 1. The difference in population can be 1 for all the districts. You can check that out. Okay, second, each district is to be contiguous. What this means is that you must be able to travel on land to every point in the district without leaving the district. So for the math students in the audience, this is what we call path connectedness. Now, there are exceptions, like Hawaii gets an exception, and so on. But, and this is a pretty easy thing to check also. Okay, and then third, each district is to be compact. So who knows what compactness is? Okay, you think you do. Okay, so the word is not used in the usual mathematical way. So not only is it not easy to check, we, meaning Americans, don't even agree about what it means. So we'll come back to this in a second. So these three criteria were established in a number of Supreme Court cases in the 1960s. The equal population requirement was a direct result of a 1964 case in which Earl Warren's Supreme Court struck down Alabama's legislative boundaries. Alabama has a really interesting redistricting history. But check this out. In 1964, they hadn't redistricted since 1900. At that time, their least populated district had 6,700 individuals, and the largest had 104,000. Okay, that cannot happen now. So since the 60s, but you know, many of us were alive in the 60s. We remember this stuff. Okay, so but that can't happen anymore. This is a computer-drawn map, so there's a lot of people who say, why don't you just draw maps with computers? Here's one, and this was done in order to optimize compactness. If you compare this to some of the districts that you know what they look like, and we'll be looking at a few more in a minute, you might notice that compactness is really more like what in mathematics we would call convexity. Okay, so I'd encourage you to think in that direction. Right now, 18 states require their districts to be compact. 37 require them to be, get this, mathematicians love this, reasonably compact. Okay. But few states define what compactness actually means. And I think the Minnesota situation illustrates that people don't feel comfortable with this. So as Andy said at the beginning, following the last sentence, I was honored to serve on the Minnesota Citizens Redistricting Commission, and this thing at the bottom is a screenshot of our webpage. On November 4th, plans are supposed to be turned in by February, by the way. So on November 4th, we were like deep in the throes of drawing these maps, and a Minnesota court order was issued about compactness. It required that all submitted plans measure compactness of the proposed district using 8 different measures, and there they are. Okay? Now, there was a plan put in by the Democrats and a plan put in by the Republicans. When you looked at them, the Republican plan won by 4 measures, the Democratic plan by the other 4. And not only that, it's worse. 2 of them are multiplicative reciprocals of each other. It's crazy. It's absolutely crazy. Okay, so, yeah. So I want to tell you what a few of these measures are so you actually just have a little bit of a feel of what we're talking about. The first one listed, the Roeck measure, is widely used, and I want to explain it first. It's also one of the older measures, being first described in 1961. Okay, so the Roeck measure uses the circle as an ideal district. Think about that, whether that's a good idea or not. Okay, think about tiling a state with circles. Okay. Okay. So you start with the district you want to measure. You draw the smallest circle possible that includes that district. And the numerical measure is the ratio of the district's area to the circle's area. So what would you, so the district here is this green thing with the greenish outline. What would you say that measure is, roughly? 0.2, 0.3, something like that? Everybody kind of on board with that? Like a quarter, a third of the circle? Okay, so good. The Roeck measure is always between 0 and 1, and it's 1 for a circle. And the circle's the only thing it's 1 for. Okay, notice, too, that this measure only takes district shape into account. It does not, for example, take into consideration the spread of the population in the district or the shape of the state the district sits in. So if you imagine you're a redistrictor and you're working in Maryland or you're working in Nebraska, you know, consider the job you have before you. Okay, so we'll come back to this in a minute. 2 other of the 8 required in Minnesota are the population circle and the Polsby-Popper measures. Okay, so on this slide you see their definitions. The population circle is like Roeck, except for we use population instead of area. Okay, and then the Polsby-Popper measure, it's a little bit different. So you take the district's perimeter and shape it into a circle, and then take the area of the district compared to the area of that new district. So if you took if this was a district, I mean it's not, but if it were, and if you stretched the boundary into a circle, what would that circle look like? It'd be like really big, right? Okay. So again, all the measures are between 0 and 1 and are 1 for a circle. Also, I've included this formula here, which you can sort of go home and check. if you want to, later tonight, okay, or tomorrow, first thing tomorrow morning. Okay. So the Roeck and Polsby-Popper measures take their cue from the isoperimetric theorem. It says that among all planar regions with a given perimeter, the circle encloses the greatest area. It's a very old theorem. I've heard at a great talk I saw within the last couple years, referred to as the greatest theorem ever. I put a little history up there, but I'm not going to talk about this now. So there's a lot of attention from the courts and from the media on congressional district compactness. And why is this? Well, another Supreme Court decision, this one in 1983, ruled that a substantial divergences from a mathematical standard of compactness may be symptoms of illegitimate gerrymandering. The verb to gerrymander refers to a move by Senator Elbridge Gerry to create a map that elected members of his own party 29 to 11, even though they received only 57% of the popular vote. And his name really is pronounced with a hard G. By the way, I have no idea why it's called gerrymandering and not gerrymandering. This cartoon is from the Boston Gazette in 1812. So gerrymandering is not a new thing. And while not new, it's alive and very well, and it's a truly bipartisan game, I would say. It's gotten much more competitive over the last decade with the advent of accessible and powerful software, like Maptitude is something, if you're interested in looking into that. Reform is in the air. For example, Illinois, so there's many states with ballot initiatives. Illinois has one that, if approved this November, would create an independent redistricting commission and implement new rules to reduce partisanship in the process. So now we have a little light break here. So the next 3 slides, I'm going to show you examples of current districts just to illustrate the liberties that are taken by the people in charge. So I think you'll like these. So this is Maryland District 3, okay? And it's attributed to gerrymandering in order to favor Democratic candidates. And it may be hard to see, but it's not contiguous. You cannot drive from those places to this part. Well, there's a lot of naughtiness going on there. Okay. Here's North Carolina's 12th congressional district. This is an example of so-called packing. It includes Charlotte and the interior Piedmont area. It's predominantly black, and blacks who vote for Democrats. And then, everybody's favorite, Illinois' 4th. Okay, this sits inside Chicago. It's another example of packing. It packs 2 Hispanic areas, there and there, and it maintains contiguity along Interstate 294, right there. No one lives there. Okay. So these are pretty bad. Some other ones that you might want to look at sometime are Pennsylvania District 7 and Florida District 5. Okay. So I want to just do a computation, a little more serious now. Okay, let's compute the Polsby-Popper measure for this district. So if you take a string, this slide didn't go, there we go. Okay, take a string, lay it along the boundary, stretch it out into a circle. You'll get a circle with approximate area about 1,071 square miles. Okay, the actual district's only 39 square miles. Okay, so if you put 39 and divide by 1,071, you get that, which is a pretty low number. Okay, so measuring compactness is tricky, and there are many more nuanced measures, so I just thought I'd take the opportunity to highlight work of one of my students who's now in grad school at Davis in the applied math program. Anyways, he developed a measure that takes into account both spread of population within the district and also the shape of the state the district sits in. So these are kind of models of that Illinois District 4, okay, but sitting in different states. So example 1 is a model of a district like Illinois. Models 2 and 3 are similarly shaped districts, but sitting in different states. So in each case, the light blue blocks with the numbers inside form the district. The gray area is the state the district sits in, and then the dark blue area is water. Okay? The Roeck measure treats all three of these equally, but we felt that they should be treated differently because the map drawer for the third state seems not quite as naughty as the drawer for the first state, in our opinion. And there's a notion of communities of interest when you're doing redistricting, and the map drawers for this one, for example, might have preserved a community of interest centered around a fishing trade. So you can see that the measure developed here by my student penalizes that map drawer worst. Okay. Now, I hope, yep. Back to the graph we started with. So we've now discussed what the two indices measure, these two indices here, and how they're computed. And I've also mentioned that some people believe that the redistricting process is a cause of polarization in our House of Representatives. This plot, however, casts doubts on the importance of congressional redistricting reform, since one can't blame gerrymandering for Senate polarization. Okay, so that's kind of an interesting, I think it's an interesting graph and gives us something to think about. There's a lot of current research and literature about this question. Okay, so let's recall the questions that I had at the beginning. There they are. The nominate scores are widely used, and if the New York Times, for example, often publishes op-ed pieces, news stories that use those nominate scores. Courts across the country are using quantitative measures like the Roeck measure to identify when gerrymandering has taken place, and the Gini Index is used by economists to quantify and understand income inequality. So I feel like I've kind of answered the first question there with a yes. Those are three measures used for that. So let's turn now for the last part to the second question about, can learning mathematics and the possession of mathematical knowledge enhance an individual's social mobility and therefore help alleviate social inequality? So the focus here is now on an individual's experience with inequality. So I'm going to close with a personal story in order to frame this question, my interest in it. Okay. Oh yeah. Okay, here we go. So I spent kindergarten through 12th grade in one school system in New Jersey. And some of my very first memories of school revolve around desegregation and integration. Desegregation can be defined as the placing of different races in the same physical environment, and integration refers to the actual social interaction and in that same shared environment. In 1957, the Civil Rights Act was first passed into law. Okay, this law, by the way, was a major bipartisan effort, and it's the sort of effort we lose with a more polarized Congress. The 1964 version of the law forbids racial discrimination in any activity or program that receives financial support from the federal government. So, for example, public school systems must administer educational programs without racial distinctions. In 1966, it was established that local boards of education had to assume responsibility for making the changes needed to desegregate their own school systems, and all plans had to be approved by the U.S. Office of Education. That's the Department of Ed is the successor of that office. So reading about these laws and plans is really fascinating, and is just one example. A 1966 article by the U.S. Commission on Civil Rights laid out some guidelines for these plans with the sort of frequently asked questions sections. And these questions come from that. And I think they seem extraordinary. I mean, I was alive then. I was in school, and I just can't even believe, this sort of stuff. Like, I mean, this is unbelievable to me. And, oh yeah. Okay, it's just unbelievable. Okay, so here's a picture of my first grade class, really. Okay, in the same year that that article was written. And you might think, looking at this picture, that my town was pretty white, but you'd be mistaken, actually. At the time, there were 6 elementary schools in my town. I was at one that was one of 3 at which enrollment was entirely white. Okay. The school in this picture, to which I was subsequently bused a few years later, was 97% black, and the other 2 of the 6 elementary schools were also almost all black. About a decade earlier, the Supreme Court had ruled in their 1954 decision, Brown versus the Board of Education, that I referred to a little while ago, that racial segregation in the public schools violates the 14th Amendment and also the 5th Amendment. This case, Brown versus the Board of Education, overturned the separate but equal doctrine that underpinned legal segregation. So in 1966, a group of town residents filed a suit charging that our school district was in violation of Brown versus the Board of Education because it was providing unequal access to educational resources for students based on their race. And this suit led to an order by the New Jersey State Department of Education mandating that the town adopt a plan for integrating its elementary and middle schools. So and we had only one high school. After many false starts over the next decade, my town eventually moved away from the neighborhood school concept that reflected the town's segregated housing patterns. Magnet schools were started, and this led to reasonably well desegregated school. But still, decades later, in 2004, many classes in my town were 80% black, or at other extremes, 85% white, and there were even classes that were 100% black with no white students in them whatsoever. And at the time, the high school student body was about 50% white, 40% black. And what happened in my town is not exceptional at all. In fact, sadly, I think you see news pieces like this recently. So this is an August article from the Washington Post titled, "A Southern City Wants to Secede from Its School District, Raising Concerns About Segregation." It's about Gardendale, which is in the northwest corner of the map, and it's about 90% white. Even in desegregated schools, we are not integrated. Okay, so after 5 decades of working on this problem, we're at a place of sort of desegregated yet not quite integrated schools and segregated classrooms. So relevant for mathematicians and math students, I got to bring it back to math. The math classroom of today remains one of the most segregated places in the United States. And the underrepresentation of minorities in advanced high school math courses is an ongoing problem. This slide shows enrollments in high school during the 2011-2012 school year by race. So I'm going to blow it up. There's a huge, I didn't know how big the screen would be. So I blew it up. The screen was big. So the turquoise chunks at the top of the left and right bars show that while 54% of all high school students are white, 64% of students in calculus are white. And the yellow chunks at the bottom show that black students make up 16% of high school students, yet only 8% of calculus students. And really, I don't think this is an acceptable situation. Is it a question of access, or is it something else? And I know that if we looked at a similar graph for low-income students, we'd see a similar, maybe worse tale, and same for very rural students. So now let me finish by running through a few facts about educational opportunity. Only 9% of kids coming from the lowest quartile of income and only 17% from the second quartile ever get a college degree. From the top quartile, it's 85%. Okay? I'm sure you're not surprised that the percent of bachelor's degree holders varies by race and ethnicity. And at the bottom, you can see some numbers. Yes. Okay. So when low-income and minority students go to college, where do they go? Well, 44% of low-income students enroll in a 2-year college after high school, and you can compare that with 15% of high-income students. Almost 60% of Native American and Hispanic students in higher ed attend 2-year colleges. To compare, only about a quarter of white students start in a 2-year college. Okay. So we see that large percentages of low-income and minority students attend 2-year or community colleges. But at community colleges across the country, the basic math requirement has been a notorious hindrance to advancement. So get this, more than 60% of students who enter a 2-year community college have to take developmental math courses. more than 70% of those students never complete the classes, and then they can't graduate in any field. You have to pass those classes to get any college degree. So the conclusion here is that over 40% of students who enter a community college never get any degree simply due to the math barrier. Okay. So what happens in math classes is critical for outcomes of low-income and minority students. And, you know, sadly, and to repeat, math courses are the most significant barrier to degree completion in both STEM and non-STEM field. And in fact, the highest predictor of actually graduating from college is your performance in your first math class. So not only is math class a college completion issue, it's also relevant in terms of college cost and debt, and I could talk about that. This is embarrassing for mathematicians. So I think more, but worse than our own pride, I mean, who cares about that? It's a national calamity, since you guys know, we all know that knowing something about mathematics leads to lots of interesting jobs and higher paying careers, and so can play a profound role in an individual's economic mobility. So this is the penultimate slide I have here, and it has a really important observation in my view. Extreme inequality is not just an accident or a natural rule of economics. It's the result of policies, and with different policies, it can be reduced. Tax, labor, education, and other policies affect the distribution of resources in a society. So working for Senator Franken, I was on his education team, and it was fabulous, but it allowed me to develop more fully my thoughts on this. So I'll just tell you a few examples of the kind of things we were talking about. So you may have heard that President Obama has been trying to make it possible for students to use Pell Grants in summer school. Or maybe not. But in any case, that's the kind of policy change that could really help certain students. And then obviously the ideas about lowering college costs that both Senator Sanders and Hillary Clinton are putting forth fall into this category. Another specific example, policies could be changed to ensure there are good full-time teachers more equitably distributed across public schools. So at one high-poverty high school in North Carolina, there was a class of incoming freshmen who had not had a permanent math teacher for the entire 8th grade. 80% of those students were not proficient in math. And this kind of gap in knowledge is extremely difficult to erase. And there's a lot of stories like this. So lawmakers could change the incentive structure to draw teachers to join and then continue teaching in high poverty schools. And in that North Carolina district, all the teachers across the district got the same pay, independent of which school they were in. So, you know, if I can ask you to remember one thing from this talk, I would say that, you know, we can all fight against inequities in society, and we should each find our own little way that we can do this. And then the last thing I'm going to tell you is that you're eligible to do so in the United States. I would like you to vote in 2 weeks from yesterday. Thank you.
Karen has kindly agreed to answer a few questions. Is Chris here? So I have one microphone. Chris back there has another one. If you raise your hand, I will run a microphone to you, although why don't we start with, it's Matt back there.
Hi, my name is Matthew Simon. I'm a junior here at Harvey Mudd, and I'm also like a public health stats major, so that's like a thing. It was cool. This was a really cool. A public health and like big data, okay. And like also some physics in there too. The question I have is like, so you labeled out like some of the biggest measures of inequality and of living standard being income, consumption, and wealth. And then, so I was wondering, is there any data or any study that shows that personal social mobility will actually affect like the accumulation of wealth, right? Because like for black and brown people, there's a lot of systems and forces to stop the accumulation of wealth, to stop people from actually gaining, even if you can gain income because of a STEM field. Is there any like proof that individual social mobility will actually help economically advantage and like socially advantage these groups?
Yeah, that's a great question. And I think, I guess I'm sure yes is the answer. I don't know those studies, but I'm sure there are. It's a long process, though. I mean, that's why I did mention that, if you're thinking about wealth, it's what you're born into, right? That makes a difference in a lot of ways. So you can enhance your own, like your social mobility, and then maybe your children and their children and their children, and so on. Is that?
Then, like, what do you do when, like, because, like, there's also, like, I read a study somewhere, I can source it at some point, but, like, where, like, in black and brown communities, every generation, the wealth decreases instead of increasing, like, in most communities, like, the community effects, just, like, what's going on, like, the fact that, like, you give it 50 years, like, this is just a sad thought, but, like, oftentimes there's just violence done on, like, black and brown communities to destroy the wealth, to make sure there's no accumulation or uprisal.
Yeah. I've seen those things too, but I don't know references. But good question.
So, others?
Hi, my name is Jenny, and I'm really interested in education in younger children, especially. And you mentioned that a lot of statistics based on college education and secondary education being a very vital part for success and wealth. What do you think about incorporating mathematics more into elementary schools? Because I know there is not much of a impact or an emphasis on mathematics in younger education right now. Do you think that would make a change?
Yeah, and I've read a paper or a couple of papers that say that if there's a gap by, I forget if it's second grade or fourth grade, but basically that gap is unerasable. So we can't let the gap start that early in math. So yes, so we really got to start early. And that's a problem with the students who come. We see that when they come to college and need to take developmental or remedial math.
And that definitely is related to the social inequality that exists, because if you're born into a black community or if you're born into a minority community, that definitely affects you at a very young age.
That's right. And chances are you're going to a school that doesn't have courses that can help you get ahead.
Hi, you touched upon the difference between income versus consumption in terms of indexes and how the Gini is still kind of the gold standard. But with bubbles like San Francisco growing, where $1 there is really not worth the same as $1 somewhere else in terms of income, how concerned are you that that standard may have to change in order to kind of adjust the picture?
So, right, that's a really good question also. So there are scalings that show, what $1 is worth in many different places. And the Gini Index, which when you're measuring income, although it can be applied to any one of those, the income would be different based on that place where you live, right? So like if you're living in San Francisco, you would make more for the same job than if you live in Omaha. So that's how it would be taken into consideration. Yeah.
You mentioned that the inequality in math classes particularly exceeds that of many other subjects. Mm-hmm. And I was wondering, so one reason I can ascribe to it is that math is sort of more building block than a lot of other courses where if you're left behind, it's harder to catch up. Yep. But are there any other reasons that you have identified in your research for why this discrepancy exists, particularly in math?
I think you kind of nailed it. I mean, I believe that math is the subject that we are benchmarked on from a very early age. And, reading and writing are similar, but there's no other subject like that by the time you get to college, you have this huge history of your math history. You don't have that with other subjects the same way. And it's very difficult to erase these gaps. I don't believe, for example, that like certain people can't do math or anything like that. I think everybody can. It's just access to good teachers and good material.
So you mentioned towards the beginning of the talk, when talking about Gini Index, that like on in both years you're talking about, it had gone up for one state, or sorry, gone down for one state.
Yeah.
You talk about like the factors affecting that, and like if Connecticut was doing something right, or if it just got really lucky.
I think I don't know actually. So there's total conjecture, but I would say that these things bounce around a lot, and I don't know if anybody else knows of anything that happened in Connecticut that year to make that happen. I think it's just. Do you know something that happened in Connecticut? Are you okay? So I don't know about that. Why that happens? Why that happened in Connecticut?
So I'm keenly aware of the late hours, so I think we'll have one more question.
Thank you. Thank you very much for a wonderful presentation. I have a question. I always wondering whether the math, think about more emphasis on reading or emphasize on geometrical imagination. So I remember in my elementary school, I think we like math more than, language class. Because, say, suppose language class, in Chinese, we write umbrella. It's the section of umbrella. A fish, you draw a fish. So the language, everything is geometric. So I think it's very important for involved students at the very beginning to imagine geometrically. So therefore, it's easy for them, the mathematics, and to look at it not by memory, but really understand by heart. So actually, I will go to a math fair this November 6th. It's called the Math Fair in Costa Mesa. And it will help middle school students study mathematics without memory of the definition, but look at it geometrically. So if anyone interested, I will drive there. Then I can bring you over there. It's just one half day. And also, when you come back, I will bring you to a restaurant to celebrate. So I already have a couple of volunteers, several volunteers, but I can bring more. Okay? By the way, those mathematical imagination will be very important. I'm teaching mathematics big data. You will see everything. I actually see a picture, support a vector machine, or whatever. Yesterday we studied maximum and estimation. I was just draw a picture, and everyone see the two steps.
Yeah. So let's thank Karen again.
And hang on, just save a little bit of applause for one more thing. As we always do with our Moody speakers, we have a gift, and Karen gets to open it in front of you.
So I have to admit, when I go give talks at other schools, I always look up your school colors and your mascot. I did find black and gold was the school colors, but I could not figure out the mascot. I now know, though. I was told over dinner. It's worse than Macalester's. I don't even know if I understand your school mascot. But, whoops. Woo!
So we have refreshments outside. Please help yourself. Come speak with the speaker. And let's give her one last round of applause.